Okay. Hi everybody. My name is Chris Hoge, and I am head of community for at Human Signal for the Label Studio community. And I want to welcome everyone to the Accelerate Your Image Annotation Workflow with Label Studio and Segment Anything workshop. As I mentioned, my name is Chris Hoge. I'm head of community, and I just try to help to support and grow the Label Studio uh, help grow and support the Label Studio community. I've been here since about October of last year, so I'm coming up on 1 year, and it's been really exciting being kind of part of this open source community and this helping to grow this data labeling platform. And I want to thank everybody who's come to the event today, who's been a member of the community and who has participated and who's currently using Label Studio. Shivant Sharma was also my co-presenter today. He's an engineering intern. He's also the author of this plugin for Label Studio. In fact, he wrote this as a student, and it kind of like led to his internship here with the company. And he's really incredible. You should check out his work. I'm excited to be sharing it. It's generated a ton of interest, and to me, it really exemplifies part of what makes open source so exciting was that Shivansh had a problem that he needed to solve. He had a pretty intensive image annotation workload that he needed to handle. Label Studio was the best tool that he had to kind of like do the labeling, but he wanted to have something to do pre-annotations for him because it was such tedious work. So he went and he built the segment anything backend for Label Studio and kind of shared that with everyone because he wanted to solve a problem. And, in the course of solving his problems, he kind of created he created this tool that is useful for other people to solve their problems. And so what we have is, and kind of the goal of this workshop today is by the end of it, you should have an understanding of how to take the segment anything model and plug it into Label Studio, but also just kind of a general understanding of computer vision problems in general, and kind of Label Studio and the Label Studio machine learning backend in general. So why don't we start the talk a little bit, talking a little bit about computer vision. And there is just a very long and deep history of computer vision and, how it's been a key critical problem for machine learning systems. It goes all the way back to, this kind of like handwriting recognition problem. Which is one of the earliest computer vision problems out there. Many of you probably recognize this data set. It's the NIST handwriting data set. It's just numbers. Handwriting goes in and text comes out. And this is like by today's standards, an incredibly simple problem. The images are very small. They are all black and white images. It's a very limited classification set. It's literally 10 items in the classification set. But this was an important problem, and it kind of helped kickstart a lot of the development for other computer vision problems that we deal with, that we kind of deal with today. As the field matured, as we would expect it to with computational power, we get into more image classification problems. And this is where, and this is again a very traditional computer vision problem. A picture goes into the model and some sort of classification comes out. And we can notice some differences between this where we're starting to accept more complex images, larger full color, a wider number of objects that we can classify. For the ResNet model, this can be thousands of things that you might be able to classify. And it looks at the whole image and it tries to predict, like, what is this image classification? In this case, it's a dog. Now, it also comes with some limitations, though. You're still limited to a set number of classes that you're going to be able to discriminate and to identify. There may be multiple things inside of an image. And so right now, this image is very simple. It's a picture of a dog in a grassy field. But what if you want to understand the difference between the dog and the grass? Like maybe there is, a cat in the photo also, and you want to be able to know if there's a cat in there. How would these sort of like image classification problems, tell you that there was both a cat or a dog in it, and it might return, percentages. But it's really kind of like, a very high level generalization of a, kind of like what the problem is looking like. Okay.
Yes. Yeah. Good.
All right. Thank you. Sorry about that. I'll back up a little bit. So where did you lose me? Over at the so we'll come back to this slide, the image classification slide. Um, where you have a very traditional, picture goes in, classification comes out. And you can have a kind of like this, the complexity has gone up. You can have, highly colorful images. You can have many different types of objects that you want to classify. And it's a pretty large difference between these simple black and white images with a very small number of classifiers to a larger number, thousands or more than thousands on some of these original models, like ResNet, which did a really great job at being able to identify different classes of images. And so being able to throw a picture of a dog in and say that it's going to be a dog. One of the problems, though, is that there may be multiple things in images. Images are complex, and these models aren't very well built for handling deeply complex images that might have multiple objects that you would be interested in them. So these types of models begin to improve, and we kind of get into the object detection space, where we're not just interested in classifying an entire image, but we're interested in classifying and locating multiple objects within an image. And so in this case, a picture goes in, and many bounding box classifications are going to come out. And kind of like one of the early examples of this that really was really popular and kind of was striking to a bunch of people was the YOLO model, the you only look once model, which can look at an image and can generate multiple bounding boxes around objects that it detects in it. So yeah, go YOLO. Yeah, I mean, YOLO was an incredible advancement, and was being able to like do this sort of object detection in almost real time. And it's still an incredibly popular model that's still being actively developed. And but it also comes with some problems. Like, for example, in this image you have 3 bounding boxes, which include a dog, a bicycle, and a truck. But all of these bounding boxes overlap, and so in some way there's some mixing of the signal that's coming out from each of these objects. And so even though I was incredible advancement, it still has a certain amount of limitations associated with it. There's also, again, a limited number of classifiers that you're going to be able to kind of detect with objects in the model. So this led to the development of of more advanced image segmentation models, which the goal is to assign a classification to every pixel in an image. And so an image goes in, and then a pixel map comes out. And so this addresses a lot of the problems with kind of the bounding box approach. You can have overlapping classes. It's incredibly granular. And it allows you to kind of like take in an image as a whole. And so you can see in this example, we have people are being classified in red, and vehicles are being classified in purple, and trees and foliage are being classified in green, and on the road. And this is just pushing forward the advancement of continuing with power, computational power, and speed and sophistication of the models that we're using. You wind up with different types of image segmentation. So, for example, you have semantic segmentation, where the model just looks at the picture, and everything that it considers to be part of a class is assigned a single mask. And so there's multiple objects in the same class. You can see in this photo of a party that there are a lot of people, and they've all been assigned to the same class. Table's been given a different class. Where in instance segmentation, we're interested in multiple objects, and each object is distinct. And this is a harder problem, right? This is considered to be a harder problem of like identifying the individual objects and assigning classes to those. So this was a really quick whirlwind tour of the kind of like a little bit of history of computer vision, but we have some common themes. The first is that over time, the complexity of the problems has increased. We've gone from 1-bit to full color images. We've gone from a few classifiers to many classifiers. By many, I mean thousands upon thousands. We've gone from being able to detect single objects to many objects and discriminate those. And we've also moved from very simple shapes, just like looking at an entire image, to very complex shape. And classification has been the primary problem. Given an image, we're interested in is what is in that image, right? Like what is it? What are the things that are in that image? And this is kind of a very gross simplification, but it's kind of like a higher level view of like the sort of problems that we've been trying to solve with computer vision over the years. This year, Meta released Segment Anything, and it represented a pretty strong advancement of the state of the art in this kind of image segmentation. If you go to the Segment Anything website, which I highly suggest, it's they've done an incredible job of kind of outlining what the model does and how it works and its capabilities. They describe Segment Anything as a new AI model from Meta AI that can cut out any object in any image with a single click. And they describe it as a promptable segmentation system with zero-shot generalization to unfamiliar objects and images without the need for additional training. So let's dig into this a little bit more. What does that mean? Well, they call it a foundation model. So it's a very large model that's been trained on an enormous corpus of data. But they've designed it for interaction. And, again, like you can go to the website, upload your own images and begin doing kind of segmentations right away. It gives you key point, rectangle, and mask prompts. And, so it wants you to interact with it. It wants you to, tell you points that you're interested in. It wants you to draw boxes around things or, mask things out so that you can guide the image segmentation that it's doing. Now, you don't have to do this. You can give Segment Anything a full image and it will start making predictions on it, and kind of segment an entire scene. But there's kind of a vision from the original authors that you're going to be interacting with this model. Strangely enough, text prompts are not supported in the public release. If you go and you read the original paper, they actually talk about how well the model performs with text prompts and being able to discover images based off the prompts that you have in there. But the public release doesn't support text prompts. And it's because they built this with integrations in mind. And, they want you to be able to extend it, kind of being a foundation model. And so, again, if you go and you look at their website, for building in text prompts, they actually use other models, to be able to, combinations of other models to be able to say that, like, find all the cats in a picture. And then, working with the integrations to build some masks, it will do the object segmentation of the cats. And what they really want to demonstrate is that this is a foundation model with generalized knowledge of what objects are. And, and it kind of like brings us to this idea of zero-shot generalization, where Segment Anything, where all of the models that have come beforehand, kind of have this catalog of things that it understands and is able to segment out. The idea of Segment Anything is that it literally wants to segment anything and do so without any retraining necessary, to just kind of like have it look at a scene and be able to identify different objects. So this is an example from their site where we've done a full scene segmentation, picks out a couple of dogs and a stick, some beach and some rocks on the beach. And it's doing this without necessarily having any prior knowledge of the scene that you're doing. And this sort of zero-shot generalization is really powerful with foundation models, where we're training on such large amounts of data that the model kind of almost has a sense of like what the structure of language is in the case of language models, or what an object is in terms of this image segmentation model. And it winds up opening a lot of avenues for kind of new development. And so that brings us to the Label Studio integration. So how does this fit in with Label Studio? Well, if you're not familiar with Label Studio, it's an open source platform for data labeling. And you can kind of think of it as a playground of labeling interfaces. You have a number of different types of data that are available for you to work with inside of Label Studio. And you have a label configuration that you can kind of arrange in any way that you want with a number of different types of tags or labels to be able to solve a number of different problems. So you can see here that we have a huge list of like pre-existing templates that you can do annotation problems with. An editing interface for you to be able to add on to that, and and a number of like different advanced configuration templates that you can use. In addition to this kind of flexible interface for managing data and loading data and creating labeling interfaces, we also have a flexible machine learning API that that allows you to plug in external prediction engines and be able to automatically label the data that and kind of assist you in being able to load pre-annotations. And so for the rest of this talk, we're going to be actually working through the example of how you can use the segment anything model with Label Studio and how to get it set up and build it into your own workflows. And so this brings us to the demo portion of this. And so we're going to be doing all of this live. I'm going to be coding it live in front of you. So doing the demo Highwire act, where all the way from the beginning of running Label Studio to configuring your project, to getting the segment anything model, to running the segment anything backend, connecting it to Label Studio, and then labeling the images. And so with that, let's get started. And I'll be working from a tutorial that I recently published about segment anything. This is what the this talk is based off of. So I'll have a link for this at the end of the talk. If you wanted to be able to follow along and kind of work on this on your own. What we're going to start by doing is just all of this code is available too, so you should be able to go and find this on GitHub and begin working right away. And so we're gonna clone the repository, and we have this Label Studio machine learning backend repository, which includes a number of examples. We have an examples directory, and inside of here, we even have like BERT models, OCR. We have the segment anything model in here. So, and this includes a Docker file to be able to build a to kind of like wrap up the segment anything model, as well as a Docker compose file to help you start up the model and run it. So if we go into this examples directory, we can do we can build this Docker file. And one of the nice things about that I like, I like working with Docker to kind of run through these sort of examples and to kind of try things out, because Docker gives you a nice encapsulated environment for you to be able to host software, try it out, not have it right all over your system. It's available on Mac OS, Windows, and Linux, which is kind of the natural host for it. With a bit of advanced configuration, you can pass through GPU instances, and so you can actually take advantage of GPUs if you have them available. I just really like using it for examples and kind of working with. So to build the image, it's pretty simple. You type Docker build, you tell it the directory that you want it to work from, and you give it a tag. So I'm going to give it Sam latest, and and I'm going to call this one live, because this model takes a little while to build. Well, actually, I've already built it, and so I have a cache of it available there. But it's going to go through and it's going to pull down some of the models. It's going to do a lot of kind of like build steps. You can see I built this earlier. And it took me about looks like about 6 minutes, or about 5 minutes to be able to build the model. 6 minutes to to be able to build a Docker container. And if we do a Docker image list, you'll see that I built a ton of Docker containers. Right, I built the SAM model about 43 minutes ago. So this is running on my okay, so the model's running. The next thing that we want to do is we want to start running Label Studio. And so again, I'm going to run Label Studio inside of Docker. I'm going to execute this command here. And what this is doing is telling Docker to run an application, connect it to port 8080. So I'll be able to see this locally on my machine. I'm giving it a local drive to be able to store its database. This is an important part of starting up Label Studio for this particular example. We're going to be uploading images. And one thing about the machine learning integrations with Label Studio is the integration needs to be able to know where the images are and be able to download them. It's possible for Label Studio to enable local file serving, which means that the Label Studio instance itself can serve files. You turn this on with an environment variable. You tell it where you want to serve the images from. If you were putting this into production, you would probably be connecting cloud storage to this. And it's a little bit more of a complicated system to be able to connect cloud storage and be able to plug in the machine learning model into that. So just keep in mind that if you're putting this into production, there's going to be a little bit more infrastructure work that you're going to have to do to make this work. But for this example, this is just kind of a nice way to just get the example up and running. So in this window, I've made sure that I have the latest version of Label Studio downloaded, and I call Docker run, and it's going to start up. It's going to initialize the database. So this is just a brand new installation of Label Studio up and going. So if we come over to our browser, we're going to see that we have Label Studio Community Edition running. So I want you to pay attention to this localhost here thing too, because I'm using localhost to access this instance of Label Studio. But when you're working with Docker, localhost can mean different things in different contexts. And this is going to be important later on when we start setting up the connections between the models. But I'm going to create a new account. If you don't know, Heidi is the Label Studio opossum, our mascot. We log in and we don't have any new projects that are here. And so we need to create a new project to start labeling our data. So let's go ahead and do that, right? We want to create a project for image segmentation. So we'll call this project segment anything. We want to import some data, and for our example, we want to be able to label images that have dogs and label images that have opossums. And so here's where I'm uploading the data to Label Studio. There are a bunch of different data management options, including connecting to cloud storage. But for this example, we're just going to upload the images directly. And then we're going to go into, building our labeling setup. Label Studio includes a ton of different templates for different application types. But for this case, we're going to build our own image detection template. And so we're going to go into the editor here for a custom template. And then we're going to copy and paste this configuration. And so configurations are they're XML files with a number of different tags that allow you to set different things up. So everything is wrapped up in this view. And we start off, we're going to be labeling images. And so we have an image tag. And some of the important values of this are, we have the name. So the name, is an identifier for the tag that we're going to be referring back to later. The value kind of refers to the image reference inside of our labeling database. And so, we're also calling it image. When we load the data, you'll see that there will be a column called image that kind of refers to all of the images that we just uploaded. We're going to have 3 different types of labeling tags. We're going to have brush tags. In this case, we want 2 tags to choose between dogs and possums. We're going to have key point labels. And so being able to drop a key point inside of an image and do automated detection based off of that, as well as rectangle labels, including some headers to, be able to identify these nicely in our interface. And you'll notice that on all of these labels, we give them a different name. And so we have the 3 different types of tag. But we're also telling the labeling interface like what it is that we're labeling. And so the tag goes from the tag label to this to name, which is the image that we defined up here. Okay, so with that, it looks like our labeling interface is set up and ready to go. You can get a visual representation of that. Too, if you want a visual editor of this, and we can select save. Right. Remember before when we had that, the name, we had the images there, and all of these images have been uploaded with image there. So, and if you open this up, you can see that we have a nice palette on the side of here where we can pick different types of brushes. We can kind of do this image segmentation. We can select different tags, being able to kind of, do the things that we want to do. But as you can imagine, like brushing out an image like this can be just incredibly time consuming, just a ton of work. And this is where we want to bring in the machine learning aspect of this. So if we head over to the project settings, you'll see that, we have our general information that we just set up. You can provide instructions to users inside of this. And we also have a machine learning tab here, or we can plug in a machine learning model. Okay, so let's show you how to set up segment anything. And we're going to need a few bits of information to be able to do this. The first is the model itself is going to need an API token. Label Studio provides you with API tokens to be able to to be able to access the Label Studio API. And so we can copy this out. And when we head back over to the segment anything model, you notice that there's a Docker Compose file in here, and we're going to set some configuration parameters in here to help us with the Docker, to help us run the model. So if we open Docker Compose, you're going to notice that there are 2 environment variables down here. The first is the Label Studio host, which is where Label Studio is being hosted. We'll get to that in just a moment. And the second is the Label Studio access token. And we can just paste our access token into there, and it's ready to go. Now, on the Label Studio host, you might be thinking that, well, I can just I know where Label Studio is running. It's on localhost on port 8080. But this isn't quite right. The reason being, this comes back to how Docker works. Docker creates these completely encapsulated environments. And when you look at Docker kind of externally, like the containers that are like running on your system, you can access them through localhost. Localhost is a special host name. It says the machine I'm on. But inside of a Docker container, localhost is actually going to point to something else. It's going to point to the container that itself is running. And so if I put localhost in here, the machine learning model will actually look at itself as the network location that it wants to find. And it won't be able to connect because it'll connect to the wrong address. So you want to actually find the IP address of the machine that you're working on. There are a few ways to do this. You can go into, say, your system settings, and you can look at your network settings, say, and bring up the details there. And you can see, for example, like your local IP address. You can copy that out and instead use that as your IP address for this. Or if you're running Docker on Windows, or you're using Docker Desktop on Windows or Mac, there's also this host name, host.docker.internal, which actually points to the host that you're running your system on. And so, either of these will work. I kind of like using the host.docker.internal because if my IP addresses changes, it'll be able to find that. So this is just a little trick for you to be able to know and be able to kind of understand how this works. The reason why this is important is the model needs to be able to know where the Label Studio instance is so that it can go and pull the images instances from it. Query the API and say, hey, where are the images from? And then be able to download the images. And so we set this, and then we run Docker compose up, which will bring up an instance of this model. Okay, so with that up and running, we come back to Label Studio. We head back over to our projects, to our segment anything project, go to our settings, machine learning, and then we can add a model. So we'll give the model a title. We'll go to host.docker.internal. We're running this model on port 9090. This is part of the configuration of the segment anything backend. We can toggle the switch for use for interactive pre-annotations. This is going to enable a lot of our magic tools for being able to be able to run this. And then we hit validate and save. All right. And if all of your connections are working, you'll get a positive thing here that says it's connected and ready to go. If I come back to this, I'll use this example of just to give you an idea of what happens if we try to use localhost to look at this. We hit validate and save. It's not going to be able to connect to the model, right? So this is why it's important to use those IP addresses or use the use these special host names to be able to look at it. Okay. So let's come back to our project now that we validated that. So let's give it a try, right? We have actually let's use a different image. Let's use the dog image because we can see all of our labels here. Okay, so in our labeling interface, we have all of our different types of labels down here. And you'll notice to the right that we have a toolbar here, and at the bottom we have auto annotation. We want to turn that on to be able to enable our machine learning interface. And you'll see this box appear up here at the top, auto accept annotation suggestions. You actually don't want to click that because we want to be able to refine the suggestions that come out of segment anything into the model. So in this case, we want to label a dog. And so let's start just by using the rectangle label and see how that does. So we select the rectangle label. Notice these numbers here on the labels, which allow you to kind of do quick switching between the different labels that we want. So we're going to select the dog label. And then over here on the right, you'll have these smart tools that have come up, which allow you to work to send predictions over to the machine learning interface. So you're going to you want to make sure you have the rectangle selected, and then select the rectangle label here, and you can draw a rectangle around the object that you want to segment. And it takes a few seconds to do this, but the rectangle was sent and the image were sent as a prompt over to the machine learning backend, and it comes back with a prediction of the model. If we head over to where we're running the model, you can see that some processing happened there. So a few notes here too. When we set the model up, we actually have a choice of different models that we want to run. And so I'm actually running on a Mac, which means I don't have a GPU available to me for the segment anything model. So I'm doing all of this on CPU. And to help speed this up, I'm actually choosing a model, in this case, Mobile SAM, with a, which is able to run on CPU and will run a bit faster, but this comes at the expense of accuracy. Okay, so heading back over here. So yeah, that looks like it did a pretty good job of segmenting this. And so I want to accept this label. And so I exit the machine learning interface by clicking the positive check mark there. And we've segmented a dog with confidence level 97%, right? And if I'm happy with that, I can choose submit. And that labeling task is done. So let's go on to another labeling task, maybe something a little bit more difficult. So here we have a picture of a possum. It's a very low contrast image. And so the possum is gray, the sky is gray, the fence is kind of this green-gray color. And so maybe if I like try my rectangle labels again, so I choose 6 for my rectangle label, I have my magic tool selected, and I draw the box around that. You can see that it actually didn't do that a great job, right? Mobile SAM can be a little bit more, it's not as accurate, and it gets a little bit confused about between what is the fence and what is the possum. Okay, so maybe we're not very happy with that, and so we reject that. We can get rid of the label that we have there, and so instead we're going to try using some key point labels. And so we select the key point label here. Let's make sure that we select that. We select 4 for the possum. And then we can start dropping both positive and negative key points into this. And so if I just click on the image, you'll see that it'll drop a key point, but this is actually worse than the rectangle label, right? Like we picked up a lot of the fence in this case. But I can also drop anti-key points. So if I hold down the Alt key on Linux and Mac machines, or the Option key on Mac, I have to reselect my label. But I hold down my Option key and I drop an anti-key point there, and you can see that it actually goes through and it negatively selects. And so we can kind of just go through and select 4 for possum, select an anti-key point, maybe try to, clear out the sky here. We want to pick up the tail. So, add a key point to pick up the tail, and, this is still a little bit more tedious than, than just segmenting automatically. But you can see that we're getting a pretty good representation of the image there. And so, we feel like this is a good start. We kind of like got a rough cutout of the object here. We can accept this, and then we can actually go back and select the mask and do some fine annotation on this using the brush annotation tool, right? And so we can just kind of like continue to add to the image, maybe refine it a bit, use the eraser tool to pull out some of the sky that was picked up here, and just refine our mask, using both a combination of segment anything in our manual annotation process, and this is like, kind of like where the art of data annotation comes in, where you want to automate this process as much as possible, but there are going to be things that the machine learning objects won't be able to pick up as well. And this is where the real power of this comes in, is being able to use both a combination of machine learning and human interaction to kind of be able to like refine these models. And so with that done, we can hit submit, and we have another thing labeled, so let's just go through and like, see if we can quickly do some labeling on all of these. And so choose some key point labels, make sure that we have the right thing selected, do some key point, and you can see here that it does a pretty good job of like recognizing that the fingers aren't part of the possum. So accept that, submit. Lower confidence level, it's kind of unsure what's going on with this. Image with multiple things in it, so let's label this as a dog. Hit submit from there, and you can kind of see just like how quickly you can kind of go through your entire labeling process. Just kind of like doing annotations. Let's see. Being, wanting to, do some refinements on this. right? Being able to accept that, submit that, just kind of be able to like work through this data really quickly. And then when we're ready, once we kind of done this annotation process, we can export our data. So, we've annotated some of our images. We can see, how many annotations we have. You can work with multiple annotators on this. And you can hit your export button. You can export in a number of different formats. For this, we'll just export it as a JSON file. And you can, export into JSON and like, have this be loaded up into whatever other project you wanted to be able to look at there. But yeah, that kind of, covers the demonstration. If I'd love to open it up for questions now. Yeah, I would love to, any questions about this. You can feel free to ask either in the chat or directly over voice. We have some questions in the chat here. Yeah, so right now Sam is working with, like Sam as the base model is it's built to just do image segmentation. So it's not really it's actually not even built to accept text prompts. If you want to do some sort of text prompting, you'll want to bring in another model. But the nice thing about the machine learning backend is you can kind of bring any model that you want to it. And the main components that you need to be able to kind of like do this are, if we look at the where's the model.py file. You basically need to import this machine learning base, so this Label Studio ML base, and then you have to implement a predict function. And the predict function has kind of, an expected input and output. But you can plug any model that you want in, and and kind of like follow this format. And as long as you're outputting the data, back to a format that your image annotation format understands, you'll be able to kind of plug in any model you want. And so Sam doesn't necessarily work with text prompts, but it does, you can take your own bespoke model if you need to be able to do like image to text, or if you want to be able to use text to image prompts. Like, you can actually have an annotator fill in a text field, and then when you select the automatic annotation, you can actually have that text transmitted over, and then use that as a prompt for the machine learning. So it's a but this would require implementation on your own side to be able to do this. Okay. Well, I want to thank everybody for joining me today. And we have a couple of links here. This first QR code on the left just takes you directly to the Label Studio website, Label Studio with a .io at the end of it. All of the things that I did in this tutorial are outlined in a blog post that I published a couple weeks ago. This QR code will take you directly there. It includes all of the examples. We have a Slack community that we would love for you to join if you want to ask any more questions, get involved. So, if you submit your own ML model. Yeah. And thanks everyone for joining me. And I hope you all have a great week.